Hello everyone and welcome back to my channel. Here we are going to study about internal memory, how we can use in Fatek PLC with the help of winprolader software. Let's start. First of all, I will search my winprolader software. Here is my winprolader software app and just one click and open this one. And first of all, I will start to take backup of my PLC. Directly goes to the connect to the PLC and click it no, because of there is any file inside that open and can be easy to check inside your PLC what's the program, this is important or not important, and also if easy to make any communication and click it, check it auto okay, and you can see your COM port and connections, everything is it's ready. And after click it okay, and he says can connect to the PLC port number COM4 and number band rate and extra, and click it yes. As you click it uh, okay, this will be shown your window in for password. If you have a password inside, you have to be right password. If not have password, you can go directly into your PLC. So my PLC is now connected successfully with my PC, and which program is inside my PLC, that's shown in ladder. So first of all, what we do, we will delete this all software, control A, and you can make it and delete. Also you can edit under running program, but if you know like to this is at the next level, I will tell you how we can in edit in online. But now this is simply we go to the stop PLC, okay, and make it click it yes, and then you click it control A and then make it delete, and your program will be complete deleted from your PLC. As you see, here is all program is now deleted, and your main page ladder diagram is completely open. So first of all, we will take one bit from the bar in the pop-up window and click it here, and I will choose the internal memory M0.0. No, sorry, M0. In this winprolader, only this internal memory represented starts from M0 to M1911. Also have other bits, later on I will tell you. So click it OK, and now your M0 is ready inside the program. And in previous lecture already I told, that's the set command out coil. You can make it here, click, and you can make M10 for example. This is M10, and in simple way, this first small ladder we will write in the PLC to run PLC, and your PLC is done. And as I click this one, simply click it on, your M10 will be on, but it will be not stop. If you will make it stop off, but your M10 will be not stop, because of this is you used set condition. Here is it, all bits I will explain you. This is the open bit, this is the close bit, this is the rising edge, this is the falling edge, this is your simple coil, and this is your inverse logic coil, and this is your set coil, and this is your reset coil. And this also same like this is set coil and this is reset coil, this is your timer, and this is your counter, and this is the function list. As you click on the function list, you will be find when if for example we like to make it here any function, we will got it here some functions. Let's start from basic. In the basic, there is a mcc, skp, skpe, many various different. That's move command, this move slash command, toggle, plus, minus, slash, plus one, increment, look like. After have timer counters, output operations, set, reset commands, this FFC, SFC functions, arithmetic commands here. Also you can got here integer to fraction, F division, many of commands you can see it here. After logic operation commands, AND logic, OR logic, XO OR logic, X NOR logic. Here is a compare commands. Here is a data movement commands. Also have shift rotate commands, bit how can we shift left to right and how can shift right to left. After code conversion have functions, have flow control functions, temperature controls, IO functions. Also have accumulate timers, watchdog timers, high speed timer counters, report printing, ramp soak, communications part. This is link 1, link 2, mode bus communication or some link, table manipulation, matrix manipulation, NC positioning controls have also, interrupt controls also have, floating point numbers, other instructions has STAT. So we will start with the basic. When we start off the basic, we for example we will use this one move command and we will take it OK, and your move command will be here. For example, I will take any data D0 and this one I like to move in D10 and click it OK. After this command will be radiate here, and this D0 why is showing minus 58 and minus 58 because of some old original settings are shown in the inside. So today our lecture is this for any internal memory how we can use. So this we don't need. Later on I will tell you. We will go back and control W and this here can fix this one back and check this one simply. Go to the stop condition and your PLC stop and go to the project. Here also you can see IO configurations and also have a memory allocation. In memory allocation I will little explain to you. If somebody listen this one already in my previous lectures, it's okay. If new persons are listening seeing my video, it will be a repeat. He says retentive coils 0 to 1400 M start from M800 to M1399. This is the total coils. And also retentive step release have total 0 to 980. Any total coils have which is retentive step release. This is coils only. This is 980. Start from S500 to S999. And also this is the timers. 0.01 second timer have total 256. Start from T0 to T49. And also this one 0.1 second timers have start from T50 to up to T199. Total 256 timers. And this also 1 second timers total have T start from T200 T255, total 56. Means first have 50 timers, after this 0.1 second have 150 timers, and 1 second timers have 56 only. And retentive bit counters also have 140. Start from C0 to C139. Inshallah will be next lectures. So we probably all uses this counters and timers and everything we will use in the lectures. Retentive data registers have 3000. Start from R0 to R2999. And ROR registers total have 3072. And reset to default and click it OK. And next he says X input contacts how much. This is start from X0 to X255. Output relay how much, Y0 to Y255. Internal relays, we are discussing about this lecture now. Internal relay memories we were using. Internal memory start from M800 to, this is retentive, M800 to M1399. And internal relay non-retentive start from M0 to M799, total 800. This internal retentive relays have 600, non-retentive relays have 800. This we are using M0 to, this will be start from M0 to up to M799. These are non-retentive relays. After internal relay non-retentive, M1400 to M1911, total 512. And special relays M912, M2001, total 90 relays. And step relays start from S500, total are 500, yani S500 to S999. And step relay non-retentive S0 to S499, total 500. Same like as here shows the timers. 0.01 second timer 50, 0.1 second timer have 150, 1 second timers have 56, and 16-bit counters have 140. These are retentive, these are non-retentive. What's the difference between retentive and non-retentive? Which are retentive bits, memory bits, or timers, or counters. This means if in case of power running, which value you stored on your program, if power goes, this will be not leave. This value will be complete inside the stored in data register. If non-retentive, we will use this timers or counters or internal relays. This will be loose memory. This will be not stored. So we will use one by one internal memory in retentive and also non-retentive. Now we are using that one, internal memory non-retentive. Start from M0 to M799. Okay. And this one, retentive relay start from M800 to M1399. First we will use non-retentive. After we use a retentive memory. Okay. This is M0 when we are using for to M10, and here we will take another bit M5 for example I will use, and here this M10 I make it set, and now I will use this one, make it reset. M10 for make it reset to the simple look like, yani this is also you can use for this one set and reset, and also holding or somewhere on off control. If you like to make, you can use this one and go to the PLC run, and simply let's ignore that one and simply see, make it on, and now your M10 is ready. And now you make it off, but this will be not leave the value because of this is the set condition. And when you click at this one, make it on, after your M10 will be reset. When you make it off, after this will be stopped, yani. As this one we will use another, yani for example this one M0 Not we will use M0. We will first stop the PLC. Yeah, this is, we will take here one rung, insert network after this network, and here we will make it one line here, and here we will use only, here we will use only simple relay M12, for example, we will use, and here we will make it, here we will make M15, and we will check this program how it will run. Make it run condition and see, as you make it on, and now your M10 is on and M12 is on, and as you stop this one, make it off, your M12 will be stopped, but M10 is not stopped, it's continues running. Oh, we will make it this one wrong, M12 have to be right, but this is M15, no problem. And as you fix this on this M5, this is already reset, yani this is M15 on, but as you make it off, this will be off. See, on M10 and make it off, this M12 is off, but M10 is on. As you make it signal, your M10 will be closed, reset, and this M15 is on. This will make it correction. M12, I will fix this one, M12, and also we will make this that same like in running condition. See, now M12 is on. As we will make this off, your M12 will be closed. But now what we like to learn, this is M10 is our non-retentive memory. For example, I make it this one on, and in meantime our power supply will be gone. I will stop my power supply. For example, I make my power supply off on the breaker, and now I make it on, but see its connection when I make it yes. After this is eject error. See, as it will be connected, this will be stopped. But in case of retentive memory, when we use that one same like, here we will take also one more, or no problem, this will we will change. This I will take, make M800, and this is also I will make M800, and that's I removed here, and this I will remove here, and I will make it here M0, and here I made M5, and this line you can connect it directly from here, and now you can download to the PLC. You're asking for password, make it OK. This is now due downloading the program. Click it OK and make it run PLC. Click it yes. And see now, as I make it on this one, now M10 is on, but this M800 is not on. Because of why we are using same bit inside, we have to be change that one. I will change this one M5 for example, and this one I will choose M8, and see, as this meantime when I make it on this also M5, because this M5 is have to be make reset for this one. This one we will choose M7, make it off first, make it off first. See M0, when we make it on, our M10 is now on, and in this time also we will make it on M800. This is because of we use one number M800 is only we use on condition, not we change the set and reset. If we use this one for set, this one control W, this one set, and this one we have to be make it reset. After you can understand. See now make it off first, and see now our M10 is also on and M800 is also on, and this is our non-retentive memory, and this is our retentive memory. And so in this time our power supply is go now for example, and as power supply will come back, we will check this one and make it on. See, our all bits are closed. Why this closed? Because of this power supply is now closed. As I make it run in put in run condition, as it I make it in run condition PLC, you can see this M10 is now stop condition, but M800 as his system is running, it will be continuously on. This will be not stop because of this memory stored in the PLC retentive. Yani any bit when we make it on, this will be not stop, but this is non-retentive memory will be stop. Now as we will give this M800 signal, after our M8 will be off, otherwise it will be continue on. But in this meantime M10 will be stopped because of this is non-retentive. Lecture I will tell you more about this internal memory settings and timers, counters and others inshallah will be soon. Thanks for watching. Allah Hafiz.